Hello there. My name's Philip, and I do security research for Cybereason. And apart from the regular reasons of wanting to share my research and shameless self-promotion, I'm doing this talk a couple of times to overcome my terrifying fear of public speaking. So this is going to be about a feature in Windows 10 called Device Guard. We'll see how to bypass it using a couple of VBA-based techniques and also a couple of non-VBA techniques. Now, most of these will not be actually serviced by Microsoft as vulnerabilities, but a real-life attacker does not really care if something has a CV or it doesn't. There's no force field that prevents them from using other non-CVE-worthy techniques. A real attacker will use whatever's at hand. So these things existing means that you will be vulnerable to them. We'll also see a couple of other benefits of the techniques I'm going to show that don't really concern Device Guard, and I'll speak a bit about how to detect these things. All right then, so first of all, let's see what Device Guard is. And Device Guard is an application whitelisting feature that was introduced in Windows 10. It's the successor to an older feature called App Locker. Now, as an application whitelisting feature, what it does is allows only code that is defined by a specific policy to run on the machine. Now, this policy contains rules such as specific certificates or hashes or even file names, and says that if a piece of code does not comply with this policy, it will be rejected by default and not be able to run. Now, such a feature actually inhibits an attacker ability to run arbitrary code on a compromised machine. Application whitelisting is pretty interesting from an offensive viewpoint, because to bypass it, you basically have everything already existing on an operating system at your disposal, because you can pretty much use any piece of code there is on the machine, because it will probably be already whitelisted. Now, to understand how these bypasses work and what they actually achieve, we need to define a bit more specifically what we mean by arbitrary code. Now, at least in my definition, it's the ability to fully and freely interact with the operating system. Where the only constraint you have is actually privilege, meaning that I'm free to try to do anything, and maybe the operating system will tell me, well, you cannot access this resource, but I should be able to at least run the code that tries to access it. And the most direct way to do this is to either have the ability to allocate and jump to code, or to have the ability to execute arbitrary API or sys calls. And it's really easy to jump between these two capabilities, because you have the sys calls to allocate and jump to code, and if you can have your own code running, you could always do whatever sys calls you want. Now, this whole silly definition really isn't important when you don't have application whitelisting, because RC, remote command execution, is pretty much equivalent to remote code execution, because you could always bundle whatever code you want in a file, in an executable file, and you have command execution. You execute your own malware tool, whatever, and you can achieve pretty much what you want. This changes the moment you have application whitelisting. Suddenly, being able to execute a command with, let's say, even a pretty cool exploit like the recent WinRAR exploit, which allowed you to write an arbitrary command to the run directory and then run whatever, this suddenly becomes much weaker, because let's say you pop calculator or notepad in your lab, and when you want to weaponize this exploit, you suddenly discover that, well, I can pop notepad on my target machine, which really does not help you, because there's a lot of offensive functionality that you need to implement, such as credential stealing or command and control, etc., which is really, really hard to do only using whatever's available on your target machine. And even if you have achieved arbitrary, full arbitrary code execution on your target machine, it's pretty easy to just lose it. Because let's say you're running in a sandbox. Maybe you have a sandbox escape, but the sandbox escape allows you to run, again, an arbitrary command, and you're reduced to using Notepad. Same thing with lateral movement and persistence and privilege escalation. Many of those techniques and vulnerabilities only allow you to run a command, meaning that you have to pair them with some kind of application whitelisting bypass. Now, let's talk specifically about device guard. The way device guard implements application whitelisting is by securing a bunch of different ways to run code. Of course, there's the most direct one, PE files. You have exes and DLLs, which will not be loaded unless they comply with the policy. There are other less direct ways to run code, which behave a bit differently. PowerShell, if you run an unsigned PowerShell script or one not signed and compliant with the policy, it will still be able to run, but it will run in what's called constrained language mode. This mode only allows very restricted types and commands to be used unless you somehow escape it or you use whitelisted script. And this means that instead of being like the ultimate Windows hacker's toolkit or whatever, you just, again, have some kind of command line tool which really isn't that powerful. The same thing goes with ActiveScript engines, which is things like JScript and VBScript. These mostly interact with the underlying operating system using COM objects, which are filtered on non-whitelisting scripts. So you suddenly are only able to use things like regexes and dictionaries instead of the usual offensive capabilities provided by COM objects and things like .NET to JScript. So if you try to run something not compliant with a device guard policy on a machine in which it's enabled, you're basically getting this nice blue pop-up which tells you, yeah, you're screwed. Right then. Now, some of the techniques I'm going to show actually require administrative privileges. And an administrator could actually just turn off device guard. So why are these even important? Well, when an administrator disables device guard, this actually requires a restart of the machine to go in action. And it also throws a pretty nasty event log. And if you're already implementing application whitelisting and device guard on your network, you should probably look for machines suddenly disabling this feature because this is extremely suspicious. So it might be nice that you could still execute, but you will be very quickly detected, or at least so I hope. The moment we have more and more administrative bypasses, suddenly this doesn't hold. You could have you could use a lot of stealthy ways to not really disable device guard and still run your arbitrary code, and simply stay undetected for quite a long time. And this really gives less reliability to the feature because device guard does not really care about users. So you basically, if you're a benign user running as admin, you won't be able to run whatever you want and you will be very frustrated. And if you're a malefactor, you will be able to bypass it, which makes it just a really annoying feature as an admin. All right, so let's jump into a couple of actual bypasses. The first few, we're going to use VBA. Now, VBA, Visual Basic for Applications, is basically the language engine that powers Office macros. And while you can't really expect Microsoft to lock down every piece of software in existence, and you should probably expect them to do only the OS stuff, this is still a major Microsoft product. And it will be pretty much on any non-server machine running Windows. So it's really weird they're pretty much ignoring device guard, meaning that if you're able to run a macro, you could do whatever you want with it. There's no mention of signing, and it will absolutely bypass device guard. And it's really easy to gain like full process control using macros. You could just import raw WinAPI functions and run your shellcode or whatever, or you could use .NET to JScript using a couple of .NET COM objects to also load a .NET assembly, which will again lead to full process control. Now, the naive way to do this is, using the GUI, opening a document, hitting that enable control button, and that's it. Your macro runs. But that's pretty lame, because this requires either user interaction, and we're speaking about a post-exploitation scenario, so we really don't want any more user interaction. I tried to search for a couple of other ways to run macros without any user interaction, without any GUI, that could be done from a post-exploitation scenario. And the first one is a lateral movement or DCOM approach. Most Office applications actually expose a COM object which is available remotely. And these allow you to actually insert and run macros into a document, or actually into like an unsaved document working absolutely filelessly. Now, it's pretty hard to use this locally under device guard, because you won't be able to interact through, let's say, a script or PowerShell, which are locked down, with the, let's say, Excel COM object. But nothing prevents you from doing this remotely. So if I'm controlling another machine and I do have the credentials for my target machine, I could just use the Office application object by DCOM and make it run a macro. So here we have a pretty simple PowerShell implementation. What we're doing is we have this string with a macro. We're doing a bit of registry wizardry using WMI to change a small key, which will allow us to actually insert a macro into an unsaved document. And then we just run the macro. And this is enough to bypass device guard on a remote machine without actually running any kind of commands locally. But, that's nice, but we still want to do this unprivileged, and we want to be able to do this locally, because like you've exploited a single machine. You don't want another machine to be under your control before you can actually bypass the device guard. So let's see what we can do here. And we need to check, when does Office simply not use protected mode, so you don't even have this enable content thing? And there are two main cases. The first case is that each document that is considered trusted, which are mostly documents for which you have already once pressed enable content, will run again, because if you trust it once and it's never changed, well, why not trust it again? The other category is documents running from trusted locations, which is the category I'm going to abuse here. So what are trusted locations? There are basically a bunch of folders that are described in the registry, which tell you everything is in this folder is trusted, forget about protected mode, and even if you have macros disabled, macros will run, because disabling macros actually only prevents Windows from creating new trusted stuff. So all of your old trusted stuff will work under disable macros. And the default trusted directories are actually only writable by admins. So for example, we have this ACC-Wiz location, which is actually the Microsoft Access trusted directory. And as you can see, I can read it, but as a regular user, I can't write it. I can't write to it, so I can't just abuse this directory as an unprivileged user. But you can see that this is actually just managed in the registry in a pretty self-describing format. You basically have trusted locations, the name of the trusted location, and a path. And here we see why it's problematic, because, well, it's fine that you can't write to the default trusted directory, But the key that manages the trusted directories is in HKCU, meaning that you could always write another new trusted directory. So you don't need the old one. All you need to do is actually write a new registry key, create a new trusted directory, which you could do always under the context of your own user. So you could do this unprivileged. So for example, I'm using ctemp, dropping some kind of database with a macro. And as you can see, I can run the macro without any user interaction. And you could also even add this nice embedding flag to the end of the command line to prevent Office from creating a GUI for any of its applications. So you don't have this pesky and very suspicious window popping out when you actually deliver and run your payload. All right. Now we understand that macros are a terrible thing to have on a machine with device guard because they pretty much break it. So let's say we want to just block VB7.dll, the VBA engine, pretty much explicitly. So this never loads. And you can do this under device guard. You can also add blacklists to your policy. So if this engine can't run, no macros for you. This is why we'll try to find some non-VBA-based bypasses. And because we're done with looking at macros, now it's time to look at a couple of macros. So VBA macros are actually not the only macro system existing in Office. There's an older system that exists in Excel called Excel 4.0 macros. And this actually exists since '92. And unlike VB7, it's actually implemented in Excel.exe itself, meaning it's a bit harder to circumvent and to block the bad part of Excel for macros. And what Excel for macros allow us is to use two functions called call and register, which will give us access to arbitrary DLL functions, meaning that we could use different syscalls, etc. But the syntax is as bad as you can imagine for something that was implemented for macros in '92, and it's pretty horrible. Now, when I first discovered Excel for macros, I actually didn't find a way to abuse and bypass device guard with it because I was only able to run different command lines and run scripts, which, as I said, are instrumented by device guard. But Stan and Peter from Outflank actually discovered a way to run x86 shellcode using this method, meaning that, well, if we have shellcode running, we satisfy one of our requirements for full arbitrary code execution. So this looks like this. We have this register function that registers an API call. Here we have virtual alloc, write process memory, and create thread, the basically shellcode usual suspects. And we are able to use them. The weird JJJJ stuff is actually how you describe a function's signature to Excel for macros. And now all we need to do is to call virtual alloc, call write process memory, and we actually can store our shellcode as an array of bytes in an Excel cell. This weird value thing is because you could store a lot of bytes in a single cell, but sometimes Excel says, well, I can't display it, but the macros can still access it. And then you just do create thread, and that's pretty much it. And you're running shellcode. Now, one way to abuse this is to, again, use DCOM. You could just drop a file with an Excel for macro embedded on your target machine, and use the Excel application to run all of the auto macros, which will execute our shellcode. And Stan of Outflank actually recently implemented a fileless version of that because the Excel application COM object actually exposes macro functionality remotely. So you could just call execute Excel for macro and give it a string with a macro, and that will do. Now, up until pretty much today, this only worked for x86 shellcode because of various data type constraints, and because the implementation of it for x64 was pretty buggy. So I'm actually releasing a small article today about how I was still able to port this to 64 bits. I'm also fixing a couple of problems with the speed of basically writing the shellcode, because it was written byte by byte remotely over a DCOM, which is a protocol with considerable overhead. So you could read this thing now. I think it's out. And that's it for Excel4 macros, or almost. This is the tool I've released, which is basically a rewrite of the original Excel4 macro shellcode tool, which will just allow you to specify, oh, here's an IP, please run x64 shellcode on that machine through Excel. And using this, like with the trusted directory trick, is exactly the same. You create a new trusted directory, you just execute your Excel4 macro file, just like you execute an Excel file with VBA, and it runs just exactly the same. Now, as I've said, the benefit of Excel4 macros, the main one is that they're implemented in Excel itself, meaning that if we can block VB7 and give you like an office without VBA to use on your whitelisted machine, you can't really do this with Excel. So you have to choose, do I want whitelisting on my machines, or do I want to use Office? And you can't have both, because this is pretty much a forever day unless Microsoft decides that either to kill Excel4 macros, which I don't know if anybody still uses in a benign context, or to actually instrument all of Office with device card. All right, so let's move on to a couple of ActiveScript bypasses. Now, ActiveScript is a Windows technology that allows you to pretty much script any of your own applications using a couple of different scripting engines. And you could also write your own scripting engine, which will be able to work with any of the compliant applications. And ActiveScript engines and hosts have been the target of a couple of recent bypasses, mostly called squibbly whatever. But we'll talk about a couple of different ones here. So first of all, let's understand what ActiveScript is actually composed of. The least surprising element is scripting engines. You basically implement a scripting engine that exposes a couple of COM interfaces which are defined in the ActiveScript standard. And the other main component is scripting hosts, which is the element that's supposed to communicate with the scripting engine and provide the host application with the ability to script itself, and the scripting engine itself with information and methods from the host application. So, for example, when you run JScript through cscript.exe, it knows nothing about HTML. But when you run Internet Explorer, then suddenly, oh yes, of course, yeah, divs and whatever. So the way JavaScript suddenly, or at least the Internet Explorer version of JavaScript suddenly realizes what HTML is because it can communicate with the MS-HTML scripting host. Now, the most common hosts and engines which are natively present in Windows are, on the host side, we have WNCScript, strobj.dll, which is the engine implementing COM scriptlets. We have MSXML 3 and 6, which implement XML and XSL style sheets. And we have MS-HTML, which is the Internet Explorer HTML engine. And on the engine side, we have JScript, which is JavaScript, VBScript, and JScript9.dll, which is also JavaScript, because we need multiple implementations of JavaScript, of course. And the way that ActiveScript works is that, at least in theory, any scripting engine compliant with ActiveScript should be able to work with every single one of the hosts, because they only communicate via these interfaces. So you can basically just mix and match. Now, how does device guard work in the context of ActiveScript? So as I've said before, what device guard does to non-whitelisted scripts is filter COM objects. So let's walk through this process. Let's say I want to create the object wscript.chill, which is not a part of the allowed objects in non-signed scripts. So I do create ActiveX object wscript.chill. The scripting engine tries to translate this friendly prog ID name to a class ID, which is a GUID symbolizing the COM object. And then it calls a function called isClassAllowed on the host, which checks our newly acquired class ID against a closed hard-coded list of allowed objects. Of course, if you have a trusted script, this check simply does not happen and everything could be created. But we have this isClassAllowed function, which checks against a hard-coded list in a library called wldp.dll, Windows Lockdown Policy. And if everything succeeds, we have our scripting engine use co-create instance to create an instance of our COM object. And if it doesn't work, you simply throw an exception. Now, not every single engine and host actually supports device guard, meaning that sometimes you don't have this isClassAllowed or it's not called. And what happens then is that you simply ignore the lack of isClassAllowed and you can create whatever. So one category of ActiveScript bypasses is to actually find a host that does not have this isClassAllowed function, which then simply silently fails and lets you create whatever. So one such scripting host is ActiveScriptConsumer, which you might know from WMI persistence. Now, the ActiveScriptConsumer actually implements in its own exe and strconst.exe its own ActiveScript host, which it does not rely on anything that I've shown in the common host slide. And it's simply not instrumented by device guard, meaning that if you're able to run it, there's nothing inhibiting you from creating any COM object that you want, and for example, use .NET to JScript to gain full process control. The only downside is that it's only available to admins. So that's a bit of a shame. Anyway, this is how you implement it. If you've ever seen the implementation of WMI persistent, this looks exactly the same. There are no other steps. Basically, what you need to do is to create an instant of the ActiveScriptConsumer class, give it the script text that you want it to run, and then you need to bind it to some kind of event that's described by WQL query, which is this SQL-like syntax. So now we have a script running command.exe every time that notepad.exe is executed, which I forgot on my VM and then got really scared that there's like a ton of command.exes running on it because I opened Notepad a bunch of times. So don't forget your research projects, or at least, snapshot, I guess. Another unenlightened scripting host, which does not implement device guard, is the MSXML libraries that implement XSL transforms. Now, XSL transforms are basically a type of file that allows you to programmatically manipulate XML files. And of course, it implements its own fully capable scripting engine, which is, again, not instrumented by device guard. So if you can somehow run and transform an XML file using an arbitrary XSL transform, you again can run unsandboxed JavaScript or VBScript or whatever. So a couple of ways to do this, again, using Office. Oh, sorry. A couple of ways to do this, again, using Office is, for example, using Microsoft Access transform.xml. So the Microsoft Access COM object has this nice transform XML method that basically allows you to use to just specify the name of a file, or actually even just a URL and a name of an XML file, and then apply your transform to whatever. So all you need to do is to access the COM object and run this method with your malicious XML file, with your malicious XSL file. And this is how it looks. You say that, well, I wanna put my result at whatever, because we don't really care, because the transform itself will fail. We only want our script to run. And then I could actually just feed my XSL file to itself, because I don't really care about the XML transformation. And that's about it. It's 4 lines of code, and you have code execution through MS Access. Another way to use XSL transforms is using the Outlook COM object, which is actually able to create arbitrary COM objects, again, remotely, using the create object function. So I could create an XML object, an XSL object, and feed the XML to the XSL. Again, running the same XSL transform code. No need to write an actual, a different payload, because this will use the exact same functionality. And again, it's not really a lot of code to use this. Right, so let's go back to this slide. This was actually a bit of a lie by omission, because we have our scripting engine getting a class ID, and then we somehow have our scripting host check it against the hard-coded list. But we don't really know how the engine knows when and what to ask our scripting host. And the answer is there's no one single implementation. So here we have actually 2 different implementations of this functionality. I could have shown you disassembly or decompilation or whatever, but it's actually much more clear from these call stacks. So on the upper image, we have the JScript 9 engine running under MS-HTML, which is, as I said, the Internet Explorer HTML engine. And we see that we have a function called canObjectRun that is run after create ActiveX object, which is basically the C++ implementation of new ActiveX object in JavaScript, at least in the JScript 9 library. And you see that it calls some function called host query custom policy, and then it calls is save to, and only eventually is class allowed is called. So the host query custom policy is actually a generic, let's say, security or safety function that also handles stuff like which ActiveX objects are available to run under Internet Explorer, and that these functions were also once the target of VBScript God mode stuff, etc. So here we see that isClassAllowed is not actually called directly. We have our scripting host, MS-HTML, say, oh, I know that I myself need to call isClassAllowed on this class ID that I got. And this is not exactly the same when you look at the bottom image, because here we have jscript.dll, and we see that it's running get object from prog ID, and then it immediately runs isClassAllowed. This means that we have our scripting host simply saying, well, you know, here's my isClassAllowed function. I'm giving you the pointer to this function. You could use it whenever. This means we have 2 different implementations. Each one of them has different assumptions as to who is responsible for calling isClassAllowed. So MS-HTML thinks, well, I'm going to call this I'm responsible for isClassAllowed. And CScript thinks, well, the developers of the scripting engine will know when they want to create their own COM object, and they will call it directly. So this works. Both of these versions work. But what happens when you try to mix them around? So the developers of JScript 9, they pretty much only meant it to be used with mshtml.dll as a host. So they had the assumption of, well, my scripting host will be responsible for checking if I'm allowed to create any COM object. So they never call isClassAllowed themselves. And the developers of CScript thought, well, there's JScript, there's VBScript, both of them try to call our function directly. So what we'll do is simply give them the pointer, and that's it. So it's, as I've said before, it's possible to run and to use any single scripting engine under every single scripting host if they're compliant with ActiveScript. So we could actually run JScript 9 under CScript. And when we do that, we actually have a scripting engine that relies on the host to do the security checks, and a scripting host that relies on the engine to run their security checks. So nobody runs the security checks, and you could create whatever. And here you can see that I'm trying to run test.js, which is a simple calc runner. And I have this error, automation server can't create object, which is what you get when you get blocked by device guard. And on the bottom command line, I'm actually specifying this /e parameter, for which I just can give you the class ID of a COM object and say, hey, use that as your scripting engine, which here is JScript 9. And the moment I run this under JScript 9, that's it. No checks are done because each of the components is relying on the other to perform all of the security checks. So this is all you need for this exploit. And this problem also exists not only with CScript, but also with strobj.dll. So it also gives you just the pointer to the isClassAllowed function, but you can't provide it with a class ID. You have to provide it with a friendly name, a prog ID. But you could always just register your own for the engine. So, for example, I could write this XML scriptlet and say, my scripting engine is called also JScript, and please run this code using also JScript. And then what I can do is just use reg or WMI or whatever to manipulate the current user's registry hive and say, hey, could you just add also JScript as a prog ID, as an alias to JScript 9? And that's it. Now you have a fileless version of the same exploit. But this was actually patched in November, meaning that, well, we're safe from that, right? Well, not exactly. So here I have a patched machine. On the top, we have the patched version of JScript 9.dll because the patch was actually applied to JScript 9.dll. And we see that it has a valid signature, meaning that, well, of course, it can work under device guard. It's a Microsoft executable, and it's signed. It's catalog signed. But if you check the older version before the patch, you suddenly see that that's also valid. So I could just use the vulnerable version. I just could, bring it from home and use the same vulnerable version of JScript 9 that I've used to exploit before, and it will work. All I need to do is to make pretty much the same modification to the current user's registry to make it work. And this was actually discovered by Jimmy Bain or Bohops on Twitter. This works for JScript 9. This works for his own recent bypass that used MSXML 3.dll. And this is pretty much borrowing a trick from driver signature enforcement bypasses, in which you bring your own vulnerable driver to subsequently load your own malicious unsigned code into the kernel. And we've called this problem catalog hygiene, because what happened here is you have a vulnerable file signed by catalog. This file gets replaced by a patched file, but the catalog does not get revoked or deleted from the machine, meaning that if you bring the file again to the machine, it's valid, it's allowed, etc. Now, Microsoft have issued a couple of new recommended block rules for device guard, which, as you see, simply mention that, oh, you have to have like JScript 9 and MSXML from this version and up, or they will get blocked. But this does not really fix the underlying problem of catalog hygiene, because this was issued in April, and at least my vulnerability was fixed in November. So you were vulnerable to a patched exploit for 5 months. So unless this gets fixed, basically patching a vulnerability is useless until you find out that, oh yeah, I also need to block these versions of the file. Also, this is not only applicable to like device guard bypasses, because you could always turn like just a regular RC into a device guard bypass. I'm so sorry for the font. I basically like drew it on a laptop with paint at night. But as you can see, these are a couple of, I think, Project Zero bugs that were found in JScript and VBScript. And both of these actually still exist on the machine. The catalogs don't get deleted. So if I have an exploit for these fixed vulnerabilities on a patched machine, I could always find them. And apparently, pretty much all of your older system files are still present in the WinSXS folder. So I just find my vulnerable JScript.dll or my vulnerable VBScript.dll and say, well, I'm going to use the vulnerable one and use an old fix exploit on a fully patched machine. Now, of course, that doesn't really help you if you want to do remote code execution or stuff like that, because these won't be deployed. But we're already in a post-exploitation scenario, so we can choose which of the allowed code we're going to use. So let's use the vulnerable code. Now, what's the scope of this problem? Well, I first thought that catalog hygiene was something that sometimes mistakes happen and updates don't have good catalog hygiene. But I think that catalog hygiene as a concept does not really exist. So this means that every time that you patch a vulnerability, at least between like major Windows 10 RS releases, you still have the catalog and actually the old vulnerable file still on your machine. So this problem is not only relevant to JScript 9 and my vulnerability and those two that I showed in the slide, but rather, well, let's say I have my Windows 10 1803 machine, which was updated to this in April 2018. This means that every single code execution vulnerability that's somehow reachable by command line DLL hijacking, Calm hijacking, or whatever from a post-exploitation scenario is actually still a vulnerability in terms of device guard in this machine. So we don't only have like JScript and whatever, we have VBScript, new versions of MSXML, and every single vulnerability that gets patched, if you have the exploit for it and it is not immediately added to the recommended block lists, and, well, nothing gets immediately added there apparently, you basically have more and more and more and more vulnerabilities. So it's not just those three. So I believe this is a pretty big problem with device guard, because suddenly we don't have like these 2 or 3 bypasses, but we have every single vulnerability until you update to the next RS, which is, in my opinion, a bit problematic. Right, so that's it for actual new device guard bypasses. But what if we're one of, I think, most people who never use device guard or never have to work against it? Well, the techniques I have shown actually have a couple of other benefits. So first of all, these were a couple of new stealthy execution techniques. So you could always use things like Office for post-exploitation, which I'm not really seeing a lot in the wild, and I think this is a pretty cool idea. And you also have stuff like AMSI bypasses. JScript 9, for example, is simply not instrumented with AMSI, so AMSI is blind to everything you run under JScript 9. So if you, for example, use the same exploit command lines I've used for the JScript 9 exploit, this won't work as an exploit, unless you use the vulnerable version. But it's still a free AMSI bypass. You don't need to change anything. You don't need to change anything in the registry or load any libraries or whatever. There's simply no AMSI there. And there's actually another JavaScript implementation in Windows which exists natively and is compliant with ActiveScript called chakra.dll. And it also has no AMSI, but it also has no ActiveX functionality, meaning that, well, if I can create COM objects, then everything's fine. But actually, if you run it under CScript or WScript, those executables will provide you a method called wscript.createObject, which will still allow you to create any COM object that you want. Now, this will not work as a device guard bypass because wscript.createObject is instrumented by device guard. But it still gives you another nice AMSI bypass. So furthermore, you could just stick a bunch of techniques together. So for example, I could have an orchestrator running JScript 9 or Chakra to just offload any more malicious or suspicious activity to, let's say, an Excel object using Excel for macros. And then I have basically JavaScript that is not showing anything on AMSI and is not communicating with anything, and have another instance of Excel that does not load a file, does not run any VBA macros. So both of these things on their own seem really benign, and it will be a bit harder to detect than one process doing all of the malicious things that you want to. And now for a quick conclusion. So first of all, you have the tools for detecting these things. Most of what I've shown is using various command line stuff. So if you have command line logging and you look at these logs regularly, you will be able to find these techniques, whether they're used as device guard bypasses or just stealthy execution techniques. And if you look at registry and maybe a tiny bit at WMI, you will be able to see everything that was shown here. It's not especially hard. And the way I think that the feature should develop is, first of all, they should really lock down Office because that's pretty ubiquitous. And as you've seen, it basically breaks device guard. So this makes it more of a server feature. And if you want to have good device guard, like if you want to have practical device guard workstations, that you should probably still implement this in Office. And it's, it's Microsoft, it's the same company. They should be able to do that. Also, a generic solution for the catalog hygiene issue should be really important, because as long as you don't have that, you have to today you have to wait a couple of months after the patch gets released to be actually safe from a vulnerability. Which is pretty ridiculous. And also, I think that a single consistent implementation for the ActiveScript device guard should be also a goal, because I'm not sure I found the only bug stemming from these basically inconsistent implementations. Also, it would be pretty nice to just extend or give some kind of API to extend the whitelisting models to other applications. Because, well, let's say I have Java. This could also be used to break device guard because it does not look at Java files, et cetera, et cetera. Same thing with Python. And, well, I think last thing I want to say is I'm hardly the first person to look at device guard and at bypasses. And if you're interested in application whitelisting or just interested in Windows research, you should probably follow these guys on Twitter or just look at their blogs. And that's it for my talk. Hope you enjoyed.
Amazing. Thank you so much for your talk. Do we have any questions in the room? Please raise your hand. No questions? Okay, let's give another round of applause. Thank you so much for your presentation.